So in today's lab video we will learn how to draw the deflected shape of strut. So we are gonna use strut number 9, which is made of steel, and these are the dimension of our strut. 16 mm is the height of this strut and 5 mm is thickness, and the overall length is 750 mm. So we will draw the deflected shape of this strut at different end condition. So with the help of this field we will apply the load on this strut, and this digital gauge will give us the load value, and this gauge is used to measure the deflection at the different point along the length. And this whole setup is strut buckling apparatus. So this steel strut is already fixed in at fixed condition at both the end. So first we will mark the center of this strut. So the length is total length was 750 mm. After placing at fixed end condition, the span length is 700 mm. So the center point is 350 mm. So we will fix this gauge at 350 mm point. Okay, now it's fixed on 350 mm point. Now I will make it 0. So now it is at 0 point. So at now initially this whole setup is at there is no load. We are not applying any load on this strut right now. So first we will find the deflection, the deflected shape of this strut at unloaded condition. So we will move at an interval of 20 centimeter from left, and we will take from center to our left at an interval of 20, and we'll note the value. So we are sliding it at an interval of 20 centimeters. So here we can see this is the value of this strut at unloaded condition. Now we will further move at 20 centimeter and we'll note the value of the dial gauge. So in the same manner we will move this deflection gauge till this end. So in the same manner we will take the deflection gauge reading at unloaded condition to our left as well, and we'll note the deflection value at unloaded condition, and after that we will apply the load. So here we can see the load value is 0 at the strut, and also the deflection value at the center point is 0. Now we will apply the load. Up to that point we get 1 mm deflection at the center point. So we are applying the load, and in the same fashion the load is also increasing here. So the deflection at the center point is around 1 mm, and the load at this point for this strut is 1920 Newton. So in the same manner now toward left and toward right we will slide this gauge and we'll measure the deflection value at 20 mm or 2 centimeter interval. And in the same manner I will move it toward the right and will take the reading. After that, I will change the support condition and will fix it at pin fix condition, and will repeat the same procedure. So now I will tell you how to change the support condition. The rest of the procedure is the same. So with the help of this L key, I will change the support condition. The rest of the procedure for calculating the deflected shape of the strut is same. So the reading of this whole experiment will be provided to you guys in Excel sheet, so you can work out your calculation. So here we can see now we are going to fix it at pin fix condition. So this end is at pin condition, and this one is at fix. So now the strut is at pin fix condition, and the rest of the procedure is same. Now I will change the other condition of the strut as well. So now I will change the fix condition to pin. So this is how we change the support condition. So now the strut at both end is at pin condition. The rest of the procedure is same which we followed for the fix condition. So that's all from my side. Thank you so much. Allah Hafiz.